Hello, let's continue our Sudoku adventure with Schering and Inslag by PjoeterBliep. The title is named after a Dutch expression describing two things that are always encountered together. Literally translates to warp and weft, as in weaving. And indeed, our grid does kind of look like a weave. All right, so let's go over the rules. We have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have double arrows in the grid. These circles have lines connected. You can tell how the lines move by, these are going under these, right? So they're always straight, basically. The lines never turn, they're always straight. And you can see from the white here that that's trying to indicate that. All right. So digits on the circles add to the same thing as the digits on the connected line. So if this was, say, a 2 and a 6, that adds to 8. This could be 3, 5, which also adds to 8. It could also be 2, 6 again. All right, so that's double arrows. We also have sandwich sums outside the grid. So digits outside the grid tell us the sum of whatever's in between the 1 and 6 in that row and column. So if the 1 was here and the 6 was here, in between the 1 and 6, we could put a 5, and then that would add to 5. Or we could put, say, the 1 here and the 6 here, and in between 2 and 3, that adds to 5. That's fine. So whatever's in between wherever the 1 and 6 are, that adds to 5, not including the 1 and 6. And then, of course, this would use the row and add to 10. This would use the column and add to 14, etc. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so 14 is a very special number in 6x6 sandwich because it is the maximum. Now, how do we know that? Well, we know the entire column adds to 21. 1 through 6 is 21 if you add them together. Now, we also know the 1 and 6 are never part of our sum. So if we put the 1 here and the 6 here, for example, what is the in-between going to add to? Well, it's every other digit, 2 through 5, which is going to be 21 minus 7, because 1 plus 6 is 7, and that is 14. And so that's what we have to do. We have to put the 1 on one side and the 6 on the other. So these are all 1, 6 pairs in order to do that. Okay, let's do the 10 next then. The way I like to think about 10 is the outies. So the outies are what's not in between, what's not the 1 and 6, and what's not in between the 1 and 6. What does that add to? Well, it's going to be 14 minus our clue. So 14 minus 10 is 4. So outside of our 1 and 6, we need to add to 4 without using the 1 or the 6. Well, not using the 6 is easy. Without using the 1, it means we can't do 1 plus 3. We're never going to be able to do 2 plus 2 because that repeats. So the only option is to put the 4 on one side and then the 1 and 6 doing this, and then in between we'll add to 10 automatically. It'll be 2, 3, 5, which adds to 10. And so I noticed we have this 1, 6 pair here. So this isn't going to be the 1 or 6. So the 1, 6 needs to go here. The other end goes here, and this is a 4. Okay, let's take a deep breath. It does make a 1, 6 pair in this box. So these are 2, 3, 5. So maybe we should look at this 5 sum. So between the 1 and 6, we either need a 2, 3 pair, because we can't do a 1, 4 pair because that uses the 1, or we just need a singular 5. Now, this could easily be a 2, 3 pair with a 1, 6 around it. That works, as far as I can tell. So what if we weren't? I think without losing any cases, we can just think about this and, either invert it to the other way or change the 2 to a 3. That won't change my logic here, I'm pretty sure. So you can see from this that there's no way we're surrounding the 5 with a 1, 6. And we can't do a 2, 3 surrounded by a 1, 6 because there's a 5 sitting there. So actually this breaks the ability to add to 5. So that means there is no 5 here. This is the 5, and then the 1, 6 has to go around the 2, 3. And then we're left with a 4 or 5 on the other end. Okay, good progress. This is a 1, 6 pair. And so then this is a 1, 6 pair. That's what I want to say. I'm trying to think. Is that true? It feels true, but So imagine this was 6 and this was 1. Then this couldn't match this one, right? If it was a 1, that would add to 2, and we'd have to do 6 plus something that was 2. We can't put -4 in there. So this would have to be the 6, and now this adds to 7. This would have to add to 7. That would be 1. So it's either that or the other way around with 6 and 1 here. No, other way around, 1 and 6 here. This couldn't be another 6 because we can't add to 12 here and then 12 here. That doesn't work. 1 plus 11. And so this would be a 1. And so these are always the same and these are always the same, making it a 1-6 up here. These are the same digit as each other. Let's call that green. And these are the same digits here. We'll call that purple. So this is green. This is purple. Oops, this is purple. And this is purple and this is green. All right. What can we do next? Oh, we need a purple in this box, which can only go right here. So this is a 1-6. I think I've done all the sandwiches. So I think I got to think about, see, do I know this color? Yeah, this color is purple. So we've got, this either adds to 6 or 11. It doesn't add to 11 because we can't do 4 plus 7. So this adds to 6 with the 1. So all the purples are 1. It just resolved immediately. And maybe I didn't have to color, but oh well. So that adds to 6. This has to be a 2. All right. Good progress. Is there anywhere obvious to look here? 2 ends up in one of these two. 2. Oh, this is either 10 or 11. So this can never be a 2 because we can't make up that difference. So the 2 goes here. That's 3, that's 2. So this is either 5 or 6. With the 2 here, that's going to be either a 3 or a 4. Huh. Is there an... Okay, so, let's think about 10 or 11. 10 could be 4, 6, or 5, 5. So we could do a 4 here with a 6 here, or we could do double 5. Oh, no, we can't do double 5 because this one can't be a 5. So if this is 6, 4, this is 4, 6. If it's 6, 5, then we got to do 6, 5. And we can't because this can't be 5 or 6. So the biggest it can be is 4. That makes this 6 and this 4. Okay, that makes that 5. 5 plus 1 is 6, so that's a 4. This is a pair. We need a 3 here. Actually, they're done because the rows are done. We need a 3 here and we need a 5 here. This adds to 7. Unfortunately, 7 is not very pencilable because you can be 1 plus 6. Well, we know we're not 1 plus 6 because this C is 1 and 6. 2 plus 5 looks possible. This could be 2, this could be 5, or 3 plus 4. This can't be the 4, so this would be the 3, and this would be the 4. Oh, and this can't be 4 either. Either of them can be 4, so it has to be the 3, 5. Whoops. Let's just fill in the 3, 5 here. That's 3, that's 5. Okay. Because this couldn't be the 5. This is 3. Oh, hold on. No, did I mess that up? I must have. Because that broke immediately. Let's just think about this pair. Maybe that'll help. This is a 3, 5 pair. So if this is 3 or 5, this... Wait, it adds to 7, not 8. 3 plus 5 is 8. All right, 3 plus 4 or 5... Yeah, 3 plus 4 is not possible. So it's got to be 5 plus 2, which makes a lot more sense. That's 3. I lost track of what our... this is a 3 for the sum here. Lost track of what our sum was. This is 2, 4. So that's the 2, that's the 4. Over here we have the 3. That's the 2. This is a 4. Over here we need the 5 and the 5. Down here we need the 3 and the 6, and we're done. Oh, there's 2 3s in the corner as well. Here and right there. All right, cool. Nice puzzle, PjoeterBliep, and I like the theme of it kind of being weaved together. How'd you do?